Hello guys, welcome to my channel Code Cruxes. Today we are going to solve a problem based on the binary search. So the problem states that find the missing term in a sequence in logarithmic time. So let's read the problem statement. It states that given a sequence of n numbers such that the difference between the consecutive terms is constant. So we get it that it is a problem of AP. Find the missing term in logarithmic time. Assume that the first and the last elements are always a part of this input sequence and the missing numbers lies between 1 to n, like n minus 1. This means that if this is the sequence, then 5 and 15 are the part of the AP while the missing number lies between them. Okay, so first of all, let us write what we have got. So this is a problem of AP. The first and the last term is known to us. And lastly, okay, so if we know the first and the last term, we know that an equal to a plus n minus 1 into d in an AP. So we will use this formula to find the difference, the common difference, right? So in our case, the difference will become a n minus 1 minus a 0, where a is our array, divided by n. Now, why we are taking n here? Because in this problem, the n is the number of elements in AP, right? And we do minus 1 in it. And here n equal to the size of the array, right? And this, if you look carefully, our array was given as 1, 2, if I take the same example, it stated that 5, 7, 9, 11, 15, right? So 5, 7, 9, 11 and 15. So in this case, the size of the array is what it is. It is 5. That is, it is already the number of elements in the AP minus 1 because one element is missing, right? So here the formula can be this. Okay, so moving forward, we now found the difference. This is the basic crux. This is like our crux first. We got it. And now let us think of it as a linear solution. We know that for linear solution, we will search in this entire AP, and when we will reach here, the common difference of 15 minus 11 will not be equal to 2, which is 2 in our case. So we will say that here the element is missing, and we can find it by adding a that index which on whichever, like this I am talking about this. So this is 0, 1, 2, 3. So our answer will be a3 plus the difference, right? So in our case, we have to formulate it as the binary search problem. So binary search implementation, we have to think about it. Okay, thinking about it, we are clear that we will have a low, a high and a mid. After that, if I talk about implementation so that this gets cleared, yeah. So now it is clear that if the position of the a mid is on its correct position, yeah, then we are sure that our element is in which side. If the position, if I hope that you can see the text, if a mid is on its correct position, then we are sure that our element is in the right side, right? The right side of the array, because suppose here this is our mid element and it is on the correct position, right? In the AP of 5, 7, 9, 11, 13 and 15, 9 is on its correct position, so we are sure that our missing element is in this side, that is in the right hand side, and else it is on the left side. So this is our crux 2, because this will help us solve the problem. And I think we are good to go. Now we are simply have to write the binary search cases, and then we are done. So cases will be something like if a mid plus 1, if if a mid plus 1 minus a mid not equal to difference, right? Then we can say then the missing element is between them, and so we can return simply a mid plus difference, right? Or a mid plus 1 minus difference. Anything can be returned. Let me increase the text size so that you can like see it carefully. Okay, this is auto. Not 4, I want big text. I think you can see it. Okay, now you can see it, right? Okay, also we need to check for the bounds. Our array should not go out of bounds. So I think we could write mid plus 1 less than high, right? Oh, sorry, not high. It should be less than an n, the size of the array, right? Similarly, we will have to write for the low cases, like for when the element lies in the left hand side. So it will become like if a mid minus 1 is less than or equal to is greater than or equal to 0, and if the difference of a mid and a mid minus 1 is not equal to, then we'll return accordingly. So okay, I think that the crux is clear. There are only two cruxes. That first we need to find the difference, and then we need to find that if it is on the correct position, it is the crux for binary search, then we are good to go. Okay, so let us try to practice this problem. Here we are. This is our code. I have written the code. You can see that we have n, low, high, and difference found as we have discussed in the whiteboard. Then you can find mid by any of these three values. So this is the first case, that if mid plus 1 is less than n, so that we check that it is not getting out of bounds, and if the difference is not equal to the difference of AP, then we will return this, or we can also return this. Similarly for the lower cases, when we have to check in the left hand side, this is our condition to like iteration, for the iteration part. Here what we have checked, that if nums mid equal to num 0 or difference, like the nums mid is on the correct position, then we will search in the right hand side, right? This is for this, or else we will search in the left side, and this will complete our AP code. Another crux of this code is this. Like here, if you see carefully, our formula for finding is this, right? What is our formula? This, a n equal to a plus n minus 1d. When we are checking for nums mid, if it is on the correct position or not, we are taking mid minus 0. This 0 is because 0 is for the array positioning system. Remember it. I have done this mistake many times and my code was not getting submitted. Because 0 is for the array positioning system. We are in the array positioning system. So we cannot do mid minus 1. It will like shift our array backwards and our element will come to be false. Let me try to explain this thing. Suppose this is my element, right? So suppose my mid is 9th and its index is here 0, 1, 2 in the array, right? In the array. So let us check according to this formula. Here our nums mid is 9, and if it is equal to a0 is 5 plus what we do, mid minus 1, right? So mid is this, mid is already 2, and if we do minus 1 and then we multiply it by d, that is 2, then it will not be equal to 9, right? For the correct, this is what? This is 5 plus 1 into 2, that is 5 plus 2, and that is not equal to 9, it is 7. And if we write the formula we used here, that is nums mid equal to num 0 plus mid, because it is already been subtracted. 5 plus 2 into 2, because it is already been subtracted because of the array positioning system. I hope you got this point. If you did not, you can like re-watch my video or check it yourself. We are doing for this array, and hence we wrote this, not mid minus 1 but mid minus 0. It is for the array positioning system for mid minus 1, and hence I think this code should work. Let us submit it and check. Yeah, so it got submitted. Our time is less and the memory is also 01 because we did not use any more things than the variables. And so this is the end of the video. Thank you guys for watching it, and I hope you got the crux and now you can code it. Bye bye.